Hello, everyone. I'm Velio from Platform Team. Today we have a series of great speakers. I'm really excited to have them all over and speak about different challenges that we face in the industry when we work at a scale such as Snap. Pretty terrific about it. Our first speaker is Felipe Lima. Felipe is a Brazilian software engineer at Airbnb working on developer infrastructure. He's very passionate about clean, maintainable, and testable code. Outside of work, he likes to play, watch soccer, run, bike, travel, and have fun with his puppy, Chavez. Wait, I feel like you are me, but in Brazilian version. In any case, I'm really excited to have Felipe over. We met about 4 years. I think you were at We Hearted at the moment.
Good memory.
We met at, I cannot say the name of the competitor, but we were at a competitor event. And then I think you joined Airbnb right after.
Yep.
And he has been doing a terrific job at open source and really incredible things at Airbnb. So let's hear it for Felipe.
Thanks, man. I got it. Thanks, Avelio. So thanks, Avelio. Thanks, everyone, for being here this morning. And yeah, like he said, he did the introduction already, so I don't have to do it again. So this talk is about OkReplay. It's this library that we've open sourced at Airbnb about a year ago. And so before we begin, so what's OkReplay? So OkReplay is a library for Android, of course, and it's aimed at recording and replaying espresso tests. And the idea is that you can replay your network interaction in your test and don't have to rely on making external network calls. So the main goal is to make your test more reliable, more stable, so you can run them in CI, and they are not flaky. So the main idea is to have more stability and more confidence on your espresso tests. But before we begin and jump into the actual details of the library and the implementation and like the boring code, I'm going to talk a little bit about a story. Maybe it's a little fun, maybe it's not, but I thought about sharing that with you guys. So when I joined Airbnb about 3 years ago, a little over 3 years ago, I was very new, of course. I joined the Android team, and it was about 8 people at the time. And there was not a lot of a testing culture, I can say. People were not super into automated testing, and and I've been always a big proponent of that, but I just couldn't come in and start bragging about this and trying to change everyone's minds. In fact, even at the time, my manager mentioned that he didn't really believe in espresso tests, which for me was like, wow, dude, what the hell? But I just couldn't say, trust me, I had just recently joined, so I just needed some time to prove them wrong. So my goal was to slowly, convince people that testing is important, that we should all be doing that. And fast forward 3 years later, we open sourced OkReplay, and I'd like to think that I was successful at my goal of proving otherwise. We have OkReplay running on our pull requests and master pushes, so it's been stable since then. So I'd like to say that worked, and I'm pretty happy about that. I like to think that I was successful at that. So that's the small story that we had to. This mindset change, to convince people of the importance of tests, and that's a little backstory behind this library. So, but first, why? Right? Why do we need this at all? At least on our Airbnb, our app relies a lot on the API, right? I'm sure that here Snapchat is the same, and it's really hard to write a test that doesn't really depend on the API, right? At some point, you need to make a network call. You need to get user details. You need to, for example, for Airbnb, you need to get the listing. So you need the price, pictures, description, right? It's not always easy to mock that data on your test, or maybe you need to ship these giant JSON blobs of data with your tests. It's not easy to update that, right? You need to have the flexibility of relying on the API, but at the same time, you don't want to make a network request in your test, right? What if the API is down? What if there's a network is flaky? What if, I don't know, something, the listing you were requesting doesn't exist anymore? So there's all these external variables that you don't want to have to deal with, right? You just want your test to work. So that's the main motivation behind it. We wanted to have espresso tests, but at the same time have them be worry-free and not have to be maintaining them all the time. And that's the main motivation behind it. A little bit of a timeline of how, well, I need to step back first and say, what is VCR? Have VCR? Does anyone know what VCR is? Nice. So anyone else other than Avili? No? It's maybe a little too it's a very specific reference to a library, a Ruby library especially, that was released around 2010. So the VCR is a library that that was kind of started all this recording, replaying for tests. And like I said, it's a Ruby library and allows you to very easily say, oh, this is the network request I'm making. And then whenever that network request happens, it's going to store the response in a file, and that's automatically going to replay that in the future. So it's the same concept, right? And the name VCR is like the video cassette recorder thing, and that's became the standard naming for this kind of library in the, from that moment on. So a lot of libraries were created based on that. And then, so what happened is that around 2010, Betamax was created, which is a Java library that was based off VCR that does pretty much the same thing. So right, it's just literally a port of VCR for Java. But Betamax is a little, first, it doesn't work for Android. It was based on backend. It was meant for backend Java, so it was, I think it was integrated with Natty. I can't remember exactly, but it made a few assumptions about your network stack, and it didn't quite play well with Android, right? So we just couldn't use that out of the box, but it was a pretty good start, right? For when I started researching how to build this library, Betamax was a very good contender. So Betamax was based on VCR, not based, but it was very heavily inspired. So then, fast forward 6 years later, last year, OkReplay was built. Fun fact, it was my initial idea was to call it Walkman, but funny, not surprisingly, it has been already registered by Sony, so I couldn't use that name. So we ended up using this boring OK foobar name, which every other library uses these days. Not a criticizing, but it's really easy to remember, and of course it's a complement to OkHTTP because this library is heavily coupled with OkHTTP, so I thought it would be a good, it would make sense to reuse that prefix on the name. So you may or may not have seen this blog post I posted around the time they were released. You don't have to worry about this, but this is like explaining some of the stuff that I'm talking about here. If you want to look later, it's on the Airbnb's Medium page. But in that article, I talk about the test pyramid, and that's something, the main thing that I wanted to call out here. Who here is familiar with the test pyramid? You know what it is? Really? Okay, it's a few people, so about 10, 12 people. So this test pyramid is a concept, I don't know who coined it, but I got this image from the Martin Fowler's blog. Martin Fowler is a very prolific technologist and works at ThoughtWorks. It's a company that I worked in the past, and I really respect the guy. He's really opinionated. He has a lot of really nice articles. I really recommend checking out his blog. But one of the things he mentions in one article he has about testing is the test pyramid. And the main idea is that your tests are subdivided in categories, right? So you have unit tests. That's like the base of your pyramid, and that's where most of your volume of tests need to be, right? You don't wanna have your entire app tested with Espresso, right? That would be both very expensive and slow, as we can see in that that turtle icon at the top. Right, so it's $3 signs, which means very expensive and really slow to run. So imagine like testing the entire Snapchat app with Espresso. That will take hours, right? Maybe not even know if that's possible. Same for the Android app, for the Airbnb Android app. So instead, you want to have a very solid set of base unit tests that test your business logic, test your interactions between all your entities, test the communication, the message passing, and that runs really fast. So we have the rabbit there to simplify that idea. And the send sign means that it's very cheap, right? You can run that as often as you can. You run that locally, you run on CI. They finish in milliseconds or seconds. You can have thousands of them. Then once you have that solid base, you can move on to the next layer, right? So you have some tests are going to be service-oriented. That's a little cloudy concept, at least to me. I usually have a hard time differentiating between UI and service tests, but I think the main idea here is that UI tests, or sometimes we call integration tests, they drive the UI of the app, right? So they don't really go into your class, they don't instantiate your class and a call method, right? They're actually going to launch your app, they're going to click a button, they're going to assert for something is displayed, they're going to check the visual interactions in the app. And then in the middle, we have service where you could check, for example, multiple components. So we could maybe test if one module is well interacting with the other module. So they're very well defined. They're separated. It's not unit, right? Because I could say unit. Maybe it's like inside the single module, but maybe service could be communication between multiple frameworks or multiple separate components of your app. But that's not super strict. You can call that however you want. You can slice it the way you want. It's just a overall guideline and something to try to aim for, that pyramid where the big volume is in the unit. So after we're done, now that we're done with that, the basic concepts, the background, what it is and why, we can jump into how this library is actually built. And hopefully that's interesting to you guys. I want to show the nitty-gritty code and how it actually works right behind the scenes. So like I said, this library was heavily based on Betamax. In fact, I would even call it a fork. It's actually literally a fork of Betamax. And we have all these modules. We have about 7 modules now. And like I said, they are very inspired or heavily based on Betamax. So the main ones you call out here is the core, where the main meat of the work is done. So we have a JUnit module where the JUnit test rule is implemented. Espresso module where the Espresso specific stuff is done. So that means, why, right? Why do you do that? That means you can actually use this library outside of Android if you want. If you want to just use OK HTTP on your backend service, or you have just a plain JUnit test and you want to use it, you can, right? There's nothing stopping you. You can just plug in the JUnit dependency and use it, right? There's nothing Android specific in there. Of course, the API is not going to be as polished as the Espresso API because that was the main focus of this library. But you can do it, right? It's totally possible because of this modular architecture. So that's something that's important here. Another thing, there's a Gradle plugin for it. And why there's a Gradle plugin, I'm going to look into that a little later. But that's something to keep in mind. There's a sample app. Of course, most libraries are going to have that. There's an OOP library module. And that module was created because if you want to release, if you want to push a release APK, you don't want to include a debugging or testing specific library in your APK, right? So you don't want to ship to the users a test-only library. That doesn't make any sense. So the NoOp library is basically a shim. It's an empty implementation, and it doesn't do anything. It's like it just skips completely, and that's something you can include in the release variant of your app and not have to worry about pushing in unnecessary dependencies. And there's one last module which is just for tests. I don't know exactly the main motivation behind it. I think it is because you can consolidate tests from all individual modules into a single place. So it's like one place to look for all the tests. In theory, you could have tests individually in every module, but then you have to look in multiple places for that. So having a single module for your tests Maybe it makes sense. It's not necessarily a deal breaker, but it could be useful. I think it was useful in this case. And another fun fact is that a lot of these tests are written in Groovy, which were inherited from Betamax, which I dislike. Anyone here likes Groovy at all? I don't know. I don't know anyone who likes Groovy. Okay, apparently no one likes Groovy, so I'm not alone. Anyway, jumping into a little deeper into the abstractions of OkReplay, we have the tape first. So why tape, right? So VCR, have a tape, you put in a tape. I know it's kind of silly, but that's the main abstraction that the main entity that VCR created, and then Betamax inherited, and now we also inherited on OkReplay. So that's where the main interactions happen, right? So what is an interaction? An OkReplay interaction is a pair of request and response, and a tape is basically a collection of interactions. An interaction can have a request and response, and they have the properties, and they are dumped into a YAML file, right? So that's the main point of the tape. So the YAML file is just how it gets serialized. In theory, it could be serialized in any format we want it. The YAML is built in because it's very readable. It's a little easier to read than JSON, in my opinion, but in theory, you could do any serialization you wanted. Each test method corresponds to a single test file, a tape file, I'm sorry. So one test method, one tape, and the tape has a name, and the name is inferred from the test's name. So we have a method foo test foo bar baz. The tape name is gonna match that by default. Of course, you can override the tape name, but that's the default. The interactions are, like I said, recorded in a request-response pair. So you have an array of interactions in your YAML. It just includes some basic stuff about each request. So you're gonna have there the URL, the status, so 200, 500, 400. It's gonna have the headers, request and response headers, and the body. The body is dumped into plain text mode by default, and that can, I believe that is not customizable, but that should be easily changeable if need be. But the main idea here is that you can easily inspect the responses. So if you want to know exactly what each request was doing, you can just go into the tapes and see the responses, and they're going to be in plain text there. The tape files are managed in a little convoluted way because of a lack of a better way to do it. So they are read from one place and they're written to another place. So you have an instrumentation APK, right, that ships with your APK for testing. So your instrumentation APK is going to have assets, and the tapes are going to be assets of your instrumentation APK. So whenever you're replaying a tape, it just gets pulled from the assets directory and then gets read. That's easy, right? It just gets read automatically, and that just uses standard Java APIs. However, writing is not that easy because you just can't write to your APK. You just can't modify your APK at runtime, right? So let's say you're recording a test and you wanna save a response, right? You need to write the responses somewhere, the tape files, and there's no way you can inject the responses into the APK, into the assets. So what we do is we store them into the external storage directory in the device, and then afterwards, when your test is done, the Gradle plugin pulls the files out of the device and then puts them in your assets directory. So that's a little round trip we need to do in order to make sure we can both read and write. Unfortunately, I honestly couldn't find a better way. If you guys have any ideas, I'm welcome for accepting PRs or discussing other approaches. But this is a little convoluted, especially because it needs a Gradle plugin to work, right? You just can't, because it needs to pull the files from the device. But I'm gonna get into that later. This is the example tape file. So like I said, it's an YAML. It has the request in there, the headers, the response status, the response headers, and the body. I didn't put a body there because it just wouldn't fit the slide. But you get the idea. The body is plain text there. If you have a JSON in there, or if you have maybe a binary body, it's going to be garbage. Oops, sorry, but it's going to be in plain text there. So keep that in mind. You're gonna be able to inspect tape files and read responses, which may be good or bad. And we're also going to talk about that a little later. Jumping into the class hierarchy of this library, Betamax, as I said, being the base implementation for this library, was very, how can I say, it was very entity heavy or inheritance heavily designed. I think it was designed by someone at Netflix at the time, and I don't know what the motivations were, but there's a pretty deep hierarchy. Not this one. So this one is fine. So we have the tape interface, which defines some basic methods there to read, write, play, seek, and there's a memory tape which allows you to has the basic implementation for the tape interface. And there's the YAML tape, which actually does the specific YAML details of that tape class. So like I said, I think it's debatable whether or not we need three entities for that. Maybe it could be simplified, but that's the way they built it, and it works well, but sometimes not super straightforward to understand. Jumping into the OkHTP Interceptor, this is a snippet I wanted to show, which is basically the meat of the library, right? So anyone here familiar with OkHTP interceptors? So most people. So just for the ones who are not super familiar, is basically a way to hook into your network pipeline, and you can basically what's a good way to explain that? So you can hook into your networks and requests and responses and modify and change. You can change requests, change responses. You can inject headers. You can mutate body. So you can do whatever you want. Pretty much, is a way to hook into the network pipeline that OkHTP provides. And the main entry point for that interceptor. So the interceptor is this class that we inject into OkHTP. And the main class is this. The main method is this intercept method, and the chain is the class that handles the delegation from one interceptor to another. So you can have multiple interceptors on OkHTP, and whenever one is finished, the next one runs. So they run sequentially, and they can short circuit. So let's say you don't want to go to network, you just want to skip network completely. You can do that, which is something we do here, as I'm going to show. So chain.request returns whatever the request was. So on OkReplay, we have this concept of being running or not running. By default, it's not running. When you start this test and it switches to running, we could probably not avoid doing that. I don't know if it's strictly necessary for the espresso use case, but regardless, that's something that we inherited from Betamax, so it's there. So whenever it's running, we adapt the requests into recorded requests. So this is a little confusing. So basically the way it works is OkReplay has its own set of request and response classes, and OkHTP has also its own set of request and response classes, right? And they're confusingly named the same. So both OkHTP and OkReplay name request as request and response as response. So that gets a little confusing sometimes. I'll try to disambiguate as much as I can. But basically what's happening here is we're adapting the OkHTP request into a OkReplay request. So we're basically translating one class into another. The APIs are very similar, so that's not super hard. It's basically getting one object and transforming into the other one. So we get the network request from OkHTP, transform that into OkReplay request, and then we check if the tape is readable and we can find a matching request in the tape. We just replay it from the tape. Of course, this logic is a little simplified because it wouldn't fit the entire interceptor in here, but this is the gist, right? This is the main thing that's happening. And basically, we look if the tape is there. Is it readable? Can we find the matching request? We can. Okay, we just replay that. So what this replay tape method is doing it's literally skipping the network, right? It's just short-circuiting through the tape. If we can't find one, we just record the response. And what this record response method is doing is just, again, is going through the chain. So it's doing basically this. Chain.proceed is going to make the network call. So this is an OkHTTP API that's going to delegate to the next interceptor and eventually go to the network, get the response, get it back. And then what record response is doing is basically something similar to this. It's like getting the response, adapting to our own object, and then storing that into the tape. This is a snippet of what that method looks like. Still, this is a interceptor method. And what it's doing is calling play on the tape. So play is maybe a little confusing to understand, but it's basically grabbing a response from the recorded set of interactions. And then we adapt that, so we translate that response into an OkHTTP response, which is something that OkHTTP can handle. And then we add some extra headers in there. That's something, again, inherited from Betamax. This just allows you to know that this request was replayed instead of coming from the network. So if you're inspecting this response from somewhere else, you're going to see that header. So it's going to have an OkHTTP OkReplay header, and it's going to say play. Okay, and now I know it was played from the tape. And if it's recorded, it's going to say rec instead of tape. And it has a via header, which is also, I don't know, I never used it, but it's there. Moving into the tape implementation, I wanted to show what the play method looks like, which, like I said, it's very straightforward. Again, this is simplified, but it should be easy to understand. So tape can be sequential, which it means that it's played in, it has a specific order. You cannot jump back and forth between interactions. So it means that it is strict about the ordering. So it basically gets the index of the interactions array, and then finds a response and then returns that response. I honestly never use that sequential mode, but it's there if you want to use it. If it's not sequential, which is the usual case for me, it just finds a matching request in there. And then what find match request does is literally finds a matching, looks through that array of recorded interactions and finds the requested matches based on some set of rules, which I'm going to get into. If you can't find one, it just throws. If he finds, it returns that response, and that's it. The main point for getting into OkReplay is annotating your tests with this annotation. So another parenthesis here, you're going to see this is Kotlin. Some code is Java, some code is Kotlin, some code is Groovy. So there's 3 languages in this repo, and they're all mixed up together. So keep in mind you're going to have to maybe context switch every once in a while. But again, this is Kotlin. This is the OkReplay annotation. It takes a tape name. You can omit it if you want, and it's going to infer that from the method name. Has a tape mode, which I'm going to get into later, and the matching rules, which I'm also going to get into later. But this allows you to customize your tests, each test individually. The tape mode is basically this is a num. It has a few different modes, and this is very, very important because it allows you to say whether or not you want to record or you want to replay in your test. So if you say read only, it means you don't want to write your tape, right? You just want to read from it. So it's never going to try to write your tape. Likewise, if it's write only, it's always going to write, never going to read from it. And then you have to switch between different tape modes in your test to be able to record, or in order to say if you want to record or replay a test, or both. Match rules is an interface, right? And it's implemented by doesnt, and doesnt provides a few basic match rule implementations that allow you to match on the URL. So, for example, match rules.method is going to check if the outgoing request matches the outgoing request method matches the recorded method. So if you record it as a get and you're making a post now, it's not going to match, right? Same thing for URI host. So if you record it as snapchat.com and now it's like staging.snapchat.com, it's not going to match. It's going to skip that from the tape. So that's something to keep in mind. Also path, porth, so that allows you to say how you want to do the matching. And also it allows you to implement isMatch manually if you want, and then provide your own matching implementation, which can be useful if you have like more complicated rules around URL matching, or you want to use a regex, or you have more strict set of rules, whatever, that's totally fine. You can just provide your own match rule and then roll with it. This is the OkReplay test rule. So the test rule is a JUnit concept that allows you to hook into unit tests and then provide a implementation that runs before every test. So you can do whatever you want. So it has this apply method, which takes a statement. So a statement is kind of like a runnable. It's a little hard to explain. So the statement has a method called evaluate. So this allows you to do something, evaluate the statement, and then do something else afterwards. So it's kind of comparable to a before and after, right? So if you use JUnit often, you know they have the at before annotation that you can do something to set up your test methods. At after, you can tear down, clean up your database, whatever. So this is similar to that. So this is a way you can encapsulate that logic in a class and then distribute that. And some libraries do that. And this is the way we encapsulate the main OkReplay entry point for starting the tapes. So what we do is fairly simple. We get the annotation. If the method is annotated with OkReplay, the OkReplay annotation, we get it. If it's there, we return a new statement. So this is pretty much boilerplate. You don't have to worry too much about this, but the meat is here. We get the tape mode, the tape name, the tape mode, the match rules from the annotation. If you have any, maybe you don't have any, maybe you just use the defaults and that's fine. So this is gonna grab all the configuration and start the tape. So what start does is eventually is gonna call start in the interceptor. And statement.evaluate just delegates to the next test rule to run. So it's like a chain of events. In a similar fashion to how the interceptors work. So it's kind of similar. So do something and then delegate to the next one to do whatever they want. And then after the test is finished, it stops the tape. And then when you call stop, it actually writes to the file. So recorder rule also exposes, so recorder rule extends recorder, which is, I think, I have there, you can see recorder rule extends recorder. It takes a configuration and what recorder, so that's where this start method is defined. And what the start method does is gets the tape loader. So tape loader is another entity that is able to take a tape name and load from a file. So that's the main responsibility it's doing. Once it gets the tape, it sets the mode, sets the match rules, so all the configuration that you had in the annotation it sets there. And then finally, it grabs the interceptor, right? So you need an OkHTTP interceptor, and then starts the interceptor with your configuration. Class hierarchy, again, not that simple. I'm sure this could be simplified a lot, and we may or may not do that in the future. But you basically have a message object, and they have abstract message, a recorded message, so I just wanted to show the overall architecture. This doesn't matter that much, to be honest. And I've marked them individually so you know what's an interface, what's an abstract class. Again, this could be simplified, but the main entities here are the bottom, and the recorder request and recorder response. And those are the objects that, when I mentioned that we do the adapting between OkHTTP and OkReplay, that's the main entity there. So this kind of mimics the OkHTTP API. So it's very similar. Has methods, has body, has status, and yeah, not that important anyway. So finally, usage, right? So this is your espresso tests. You usually have your activity test rule, which is the thing that instantiates your activity, right? This is a Android or it's an espresso construct, not part of the library. If you're not familiar with espresso, but this is where I say what activity you want to launch, right? And usually you would annotate this field with @rule. So if I remember correctly, bear with me if anything I'm saying doesn't make sense, since this It's been a few months since I last worked on this library, but this is from the best of my memory now. So usually you would annotate this field with rule, right? So it actually launches your activity and finishes it afterwards. In this case, we don't annotate, so that's one gotcha about the library. You don't annotate you have to remove your rule annotation from your test rule. And then we configure OkReplay, so we set the default mode. So this is, let's see if this works. It doesn't work, never mind. So I just wanted to point out that the default mode is whatever is going to be used for saying if you're recording or replaying. So in this case, read-write means that I'm going to actually write to the tape if I see any new interactions. And if you say there default mode is read-only, then it's only going to replay. So typically, you would have read-only for your CI when you're when running this test on CI, and when you're running locally, you can say read-write. Then it's going to, whenever you have a new request. So let's say you're working on a feature, and then there's a new request you're making that it's not in your tape, and you want to record that. Then you say read-write, and it's going to record that new. It's going to append that new interaction to the tape. So. Yeah, it's a little complicated the way it works, and I think there's some room for improvement there in the API, but I'm going to get into that later. And the match rule is just saying that I'm matching on the host, the path, and the method. So whenever there's a URL, example.com/foo/bar, I'm going to just look at that. If there's query parameters, I'm going to ignore them. So if there's like $A equals B, that's ignored, doesn't matter. So that allows you to be more flexible in the matching, or more strict if you want. It's also not going to worry about SSL or anything. It's just the host path and method part of the URL. And that's what it's going to use to determine whether or not it finds a match in the tape. And finally, you define a rule chain, which is probably not very popular or familiar concept to a lot of people. I didn't know before I built this, but it's basically a rule change allows you to chain multiple test rules. So we can run one test rule and then another in a specific order. So you know what runs before what. So you have a structure in the ordering of what they do. So why do we need this at all? Right, we need to run this before the activity is instantiated. So we pass the activity test rule to the OkReplay rule chain. So we start the tape, and then only after we start the tape, we start the activity, right? So we have this strict ordering there. So finally, after you configure, you just define your test. You annotate it with OkReplay, and then you do whatever you want. So if anywhere in here there's a network request, if you have a tape in there, it's going to replay from the tape, and it's going to skip the network completely. Okay, so I talked a lot about the API and how it works and what are the entities and all that, but wanted to get a little bit onto what works and what doesn't. This is not super straightforward, so a lot of things may be not intuitive when you start using the library, and of course it's not that simple, right? There's a lot going on in here. So let's see what works and what doesn't, right? So permissions is a problem sometimes, right? So whenever you want to write something to the disk of the device, it's not always easy. You have to grant this write external storage permission, and that permission works differently depending on the API level. So this is basically one of the reasons we have a custom implementation that allows you to set the permission. If you don't set the permission, we try to grant it forcefully. So it's pretty cumbersome. Keep in mind, you may or may not have issues with permissions trying to store the tapes, depending on what API level you are on. So something to consider. Handling secrets is another problem. What if you have a username and password in your tape, right? So that's going to be checked into your repo, and it's going to be available to all engineers to read, right? So you probably don't want to do that. So you might need some kind of customization around maybe stripping those passwords and usernames or whatever PII, we call it PII, personally identifiable personally identifiable information, right? So I'm sure none of you want to do that. So we don't really have any built-in way to strip that from the tapes. So that's something we might need to consider for the future, having a way to automatically remove them if possible. Another thing, if your test fails, you won't have a tape, right? So that's something that may not be that clear to some people, but it's something to keep in mind, right? So if you have an assertion that failed, your test is going to fail, which means it's not going to run the post-test task that saves the tape, which also may or may not be fixed. I'm not sure exactly what we could do here. Maybe we could save the tape anyway, even if the test fails. But that's something that there's probably room for improvement there. Switching from recording and replaying is not that straightforward. Like I said, you have to set the right tape mode. So tape mode, read write, tape mode, read only, whatever. So that gets kind of cumbersome. Also, you have to do the checking. If you're in CI, you don't want to write. If you're local, you want to write. But now I want to just play. So getting that setup in place is a little cumbersome sometimes. And of course, the API could be improved. And I'm open for feedback here if you guys have any. So that's pretty much it. There's more that I probably forgot. But just wanted to say that if you want to take something away from this and if you are not already convinced of this, but please know that writing Android UI tests is possible, and a lot of companies and people have proved that. So I hope that question is already settled and there's no room there for discussion anymore. Also, it is hard to write stable espresso tests, right? It's not always easy to make them stable and not fail on CI. Sometimes it's flaky. For us, even we use Firebase Test Lab. Sometimes even Firebase Test Lab goes down, and you want to handle all those corner cases. So it's not. It needs some work to make them stable, right? So that's something. This is not a silver bullet, of course. Nothing is a silver bullet, but this doesn't mean that all your tests are going to be immediately stable, but it's going to help a lot to make you iterate faster on them. Naming is hard. I wish I could name this Walkman, but that was not possible. So we ended up this a lame name. And like I said, writing the tests, UI tests that's stable and reproducible is possible. And please do write tests. And yeah, that's it. Any questions?
This is a totally hypothetical question, but how wedded is this stack to OkHttp, and would it be possible to use something kind of like Cronet or a different HTTP layer? So you want to plug in you want to use a different network client, basically, right? I'd say it's pretty heavily based or heavily integrated with OkHttp, and if you want to plug in a different HTTP client, it won't be that easy. Again, this was based on the assumption that OkHttp was ubiquitous and most companies and libraries use it. So that was my assumption. So if you want to use a different client, it's going to take some work for sure. Yeah, it won't be that easy, but it is possible. And I would be open for that.
So would you say the biggest benefit of it was that your tests ran faster, or that they were less flaky, or that you could turn some UI tests into unit or service tests?
It's both. They were faster and flaky, because all of a sudden you can completely skip the network latency if you had any. Well, I don't think you should ever write a UI test that goes to the network, or of course you can't always avoid it, but if you do, it is going to be flaky for sure, right? Networks are flaky by design, so I would say the main benefit was it was much faster, right? We knew that after having the tapes recorded, we knew that the tests were always going to take X seconds, and the variance was very low, so we knew they were very highly reproducible, and that was good. That was a good thing to have.
So if you asked if you were more stable and faster, probably both. Yeah, that was the main goal, I'd say. Yeah.
I don't know if this is on. So what is the typical workflow for generating these tape files?
You would run your tests with the right tape mode. That's it. And then you run the test. If you have the tape mode set to read write or write only or something that writes, it's gonna, like I said, it's gonna, once your test finishes and if it's successful, the tapes are gonna be in a directory in the device. Right, and once the test finishes, if you have the Gradle plugin applied, which I didn't cover any of the plugin, but it basically looks into that specific directory and pulls those files into your local, directory. And that's it. They're gonna magically show up there if everything works. And then next time you run, it's gonna just play from there and skip the network completely. So that's the main. And then if you can prove that by setting your device to airplane mode or something, and then it's gonna still work. So that's the main workflow.
So it's the test implementer would run the test once in read-write mode and then check in the tape files?
Exactly. Yeah, you check in the tape files, and then next time they run, they're always gonna replay from the tape. Like I said, as long as it's set to read, as long as it's readable, that's it. And it matches.
How do you deal with secure HTTP?
Sorry, say it again?
How do you deal with secure HTTP?
Secure HTTP, you mean HTTPS?
Yes, or so various versions of TLS or other secure transports?
That's handled by OkHTTP directly. I don't believe, so Betamax had support for SSL, and you could say SSL enabled and all that. We don't really need to worry about that because that's all in the transport layer as far as I understand, and that's not a concern of the interceptors specifically. So you can mutate requests and responses, but you don't really go to the network, right? You just deal with a blob, so it's not a concern.
Another question that I had is why did you have to go all the way down to the network layer? Couldn't you go a little bit up on another layer, maybe have replay network responses as observables or something like this? Is there any advantage to have it at network layer?
So you're saying that you could have an observable that does the replaying instead of going to the network stack directly?
My example would be, say you have a retrofit adapter service which returns an observable from the network. Basically, you could provide an implementation which has mock data instead of having to, deal with the tapes and network. I'm kind of wondering if there is an advantage of having like the network layer.
This is a very good question, actually, and you're right that in theory it should be possible to hook into a little higher layer. So there's nothing stopping, like I said, there's nothing stopping you to hooking into the OkHTTP level and then not have to deal with interceptors at all. That's totally possible. For us, OkHTTP was an assumption, and we knew that we were still. We used OkHTTP already, and it was there, and it was probably easier to hook into that level than on retrofit, but that's totally possible, and I actually think it's a good idea. Because then you would be like network HTTP client agnostic, right? You could like just hook into a little over the higher level, and then not have to deal with that. I don't see why that would be a problem, and yeah, it sounds like a good feature request.
The second question I have is kind of off topic, but if naming is hard, how come you came with this amazing name for your dog, Chavez?
So this is we just adopted. So if Ella is talking about the dog, we just adopted, and he's called Chavez. But that's like a big. It's a reference to a Mexican TV show. That's a big part of my infancy, and the main character is it's a orphan dude that lives on the streets, and we adopted this dog, so he doesn't know his parents. So that's like the kind of the correlation we did, but we took a long time to settle on that name. So it is still hard to name.
So, kind of devil's advocate, and a question follow up to that is: is this useful for things like thumbnails and other blob content? Like, does that ever come up in your testing if you're doing UI testing, or does that not really?
For blob, you mean images?
Yeah. Right.
Yeah, I mean, you can store anything you want in the tapes, and if it's an image, it's going to be a binary blob, but it's going to be there.
Has that ever been useful for you guys? Has it ever come up?
We haven't used that first because we don't care about images in the test. We don't really assert like if an image is shown correctly, right? If it's like a broken image, we don't really test for that. It is possible that would happen. But then how do you test that? Is this something you want to test? That's the main question.
I'm just thinking, like, if you're plugging into a UI test and you have some code that either shows a thumbnail or an error, I don't know. It seems like it might be helpful there, or certainly at least to speed up your test. It also seems like it might.
It is possible, yeah. It would speed up, like because then you don't have to download any images. But again, your tapes would be gigantic because you're gonna have like image files in there. So it's a trade-off. I'd argue whether or not it's useful. I'd say not very useful for me, but maybe for you it is. Yeah, totally.
Anybody else have a question?
No? Okay, thanks everyone.